So the problem reads, the 2 height of x is defined to be the greatest non-negative integer n such that 2 to the n is a factor of x. So I rewrote that to mean the 2 height of x means the number of 2's, factors of 2's in x. Number of 2's in x. Height 2 height k, number of 2's in k. 2 height m, number of 2's in m. And by the way, I don't really like how this problem is worded. Maybe it'll grow on me. All right, clue 1, k is greater than m. But what we're trying, I didn't write down what we're trying to find. I think we're trying to find the number is number of 2's in k more than number of 2's in m. All right, k is greater than m. So that means I don't have a formula for this. I'm just going to pick numbers out. So let's just pick some numbers out. Let's let k be 4 greater than 3. How many 2's are in 4? 2. How many 2's are in 3? None. Okay, 3 is not a multiple of 2. I may be saying this wrong. Not just, it has to be divisible by it, and it's not. All right, so this is not divisible. That's going to be 0. Now 2 would go into it one time, but we're not. We want it to be a multiple of 2. All right, so let me see. So now let's do another one. 4 is greater than 3. Let's take a prime number. 13 is greater than 8. How many 2's are in here? There's 2 to the n, 2 to whatever is not in 13. So there's 0. But here it's 2 cubes, there'd be 3. So sometimes k is greater than m, and sometimes k is not. I found both of these cases, 4 is greater than 3, and 13 is greater than 8, but I got conflicting results. So that doesn't work. Okay, number of 2's in k more than the number of 2's in m. Okay, so clue 2, this one's going to work. So I've got k over m, and it says it's even. So that means m completely, all of its factors canceled out when it divided it into k. But when you divided it into k, something was left over, and that happened to be an even number. And an even number is divisible by 2. So that means 2 height m would be more than 2 height k. So the answer is B.